Uh, Good evening, and let's start today's class. So, before we move on with our string programs, there's one thing that I would like to discuss. I don't remember if I have already discussed it during explaining the arrays section, but let's just take a look at it once now. So, if you remember the definition of an array, it is nothing but a continuous collection of elements. So if I draw an array here, so it's nothing but continuous, memory locations where values are stored. So let's say I have 21, 56, and 7. So this is just an arbitrary array. The thing that I want to highlight is that, let's say in physical memory inside the computer, this particular location, which is indexed as 0, starts at, let's say, location 7000. Okay. So the 0th index, let's say for example, hypothetically, it starts at the location 7000 in our physical memory, which is the actual RAM that is present in our computer. So in computer memory, let's say the starting address of this particular array, let's call this array n. So the starting address of n is 7000. Now depending on the data type of the array, let's say the data type of this particular array is int. So depending on that data type and the size of the array, the total memory is allocated at once. So let's say I have this definition, a definition something like this. Let's say int n is equal to new int. Since you're working with 3 values, let's say 3. So once we define an array like this, what do you think the total size of the memory that is allocated to the array? So there's a way to calculate the total amount of memory that is being, allocated to an array when it is being defined. So we know the size of int is 4 bytes. We have already learned that the size of the int data type is 4 bytes. So let's say my compiler starts assigning memory from the location 7000. So since my array is of size 3 and each integer value, so the size of my array is 3, which means it will have 3 values in total. Now the size of each value will be 4 bytes because those are integer type values. So each value will be of size 4 bytes in memory. So the total number of bytes required to store 3 values of integer data type is simply 4 into 3, where 3 is the number of elements. So I need a total of 12 bytes. I hope it's clear. It's very simple. The amount of memory allocated to an array depends on 2 things. First, the data type of the array, and second, the size of the array. So let me write that down on this side of the board. So the memory allocated to an array depends on, so let's say, the amount of memory. So let me write that down properly. The amount of memory allocated to an array depends on these two factors. Number one, the data type of the array, obviously, and the size of the array. So remember these 2 points. So they might give you questions where you might have to calculate the total amount of memory that, so they'll give you an array that is defined something like this in a way, and they'll ask you what is the total amount of memory that this particular array requires. So to calculate that, you need to focus on two things. The first thing will be the data type of the array, and the second thing will be the size of the array. So if you know these two things and you remember what is the size of each data type, you can easily calculate the total amount of memory that an array will take or occupy. Okay, in this particular case, as we can see, it is of integer data type. The array n is of int data type, and the total size of the array is 3. I know that integer takes up 4 bytes, which is the size of integer. 4 bytes is the size of an integer value, and there are total of 3 values, so I just multiply them. So 4 bytes for each integer value into the total number of values, which is equal to 3 here in this case. So I take up 12 bytes of memory. So that's one thing. That's how to calculate the total amount of memory. Now let's say you have been given a starting location of memory where 7000 corresponds to the first value in the array. So what do you think will be the starting location of the second value that is stored in the array? So this particular value 21 takes 4 bytes, and each address value of memory corresponds to 1 byte. Okay, so 7000 is 1 byte. So the memory, let's say, imagine that the memory is partitioned in this way. So these are the partitions of memory. Each partition is of size 1 byte. Okay, so if each partition has a size of 1 byte, then each integer value will take up 4 bytes. So 1, 2, 3, 4. So this whole thing will be taken up by an int value, because int is of size 4. So it will take up 4 bytes in memory. Now, since each byte in memory has a single address, unique address, such as 7000 is the starting location of starting address of the first value. So if 7000 is the starting location of the first value, the next byte will be numbered 7001, and in a similar way 7002 and 7003. So the first byte is numbered 7000, then the next very adjacent byte is numbered 7001, then the next adjacent byte is numbered 7002, and so on. So the first element takes up the whole space from 7000 to 7003 in memory, which is the size of int basically, which is equal to 4 bytes. So the second array value starts at location 7004. So this is the starting location of this particular array. The value. This is the starting location of this particular element. So the second element of the array starts at 7004 because from 7000 up till 7003, it is the first integer value that is stored. So the second integer value is stored starting from 7004. Again, it will go three places in memory. So 3 addresses in memory to be more specific. So 7004 including 7004, 3 spaces would be 4 spaces, sorry, it will go 4 spaces. So 7004, 7005, 7006, 7007. So 4 spaces are for 56. So the next memory location will start at 7008. So these are just the starting addresses of each element in the array. So the first element starts at location 7000. The second element starts at location 7004. The third element starts at location 7008. I hope it's clear. It's pretty easy. Once you know the size of the data type, you just add it to the starting address, you get the next address. Again, add that to this address and you get the next address, and so on. So you just keep adding the size of the data type. So if you add 4, since integer is of 4 bytes, you add 4 to the starting address 7000, you get 7004, which is nothing but the starting address of the second variable, or rather the second value in the array. With 7004, if you add again 4 bytes, it will give you 7008, which is nothing but the starting location of the third value in the array. So that's how you calculate starting or memory. That's how you calculate memory addresses. So you will almost always have to calculate the starting memory addresses. So they'll just give you an array. They'll give you the starting address. From the array, you'll find out what data type it is. You'll know the size of the data type by default, and let's say they ask you to find the address of the nth element in the array. So you just keep on adding and find out the starting address of the nth element. There's one more way which you could shorten the calculation. So let's say the array is very big. There are 100 elements in the array. They tell you to find out the starting address of the let's say 31st location, or rather the starting address of the 31st element in the array. So the 31st element will obviously be indexed as, so just before that, just take a look at this particular example. So the index number of the third element is 2, right? I know the size of integer is 4 bytes. I know the index number of the element that I'm trying to find, the address of the element that I'm trying to find. So if I know the size of the data type, and I know the index number of the element that I'm calculating for, the address for which I'm calculating for, I'll just multiply the index number with the size. So 4 bytes, and 2 is the index number of the element in concern. So if I know the size of the data type and I know the index number for the element for which I need to find the starting address, so I'll just multiply the index number with the size of the data type. I'll get 8. This is simply added to the starting address, which gives me the base address. So let's change the terms here. This particular thing is called the base address. So they'll give you the base address. So base address is nothing but the starting address of the entire array, which is nothing but the starting address of the first element. So that is where the array starts. So the base address is the location in memory where the array begins. They'll give you the base address. So this is nothing but the base address. So they'll give you an array. So they'll give you a definition, something like this. From this you'll come to know what data type the array is. You'll know the amount of memory or the size of the data type. You'll know it by default. You should have them memorized. Now they'll ask you to find the starting location, or rather the starting address of a particular nth element in the array. Let's say there are 100 elements in the array, and they ask you to find the location, first address of the 31st element in the array. So 31st element will obviously have an index number 1 less than 31, because this is the third element. The third element has an index of 3 minus 1, 2. So the 31st element will have an index number of 31 minus 1, which is equal to 30. So let's take a look at that example. So I'm rubbing this off. So the most important part is these two things that you need to remember, and the calculation part, how to calculate. So let's take another example. Let's take another example and see how it works. So this can be generalized in this following way. So if I write it in a much more general way, so size of, so how to calculate, let's write it down fresh. So there's a formula, so you can write it in the way of a formula. So how to calculate the starting address of nth element in an array. So the nth element, n part here does not correspond to the index. It is the actual number of the element when counting from 1. So the 31st element means the counting from 1 from the beginning of the array, the 31st element in the array. So the index number will be always 1 less than n. So the formula is something like this. So size of data type needs to be multiplied with the index of nth element, which is equal to n minus 1. So the index of the nth element is n minus 1. You get something. Now the value that you will get from here, let's say I get a value, let's call this value a, for example, just taking a variable for the value. So the size of data type multiplied by the index of the nth element gives us a value a. You simply add address of the nth element is equal to the base address, which will be given to you, plus the value A, which we have calculated here. So that's the whole formula for calculating the starting address of the nth element. So you have to know the size of the data type. The index number of the nth element will be n minus 1. You multiply the size of the data type with the value n minus 1. You get another value after multiplying, represented by A. Now the address of the nth element will be nothing but the base address, which will be given to you. In our previous example it was 7000. So the base address would be added to this particular value A, which has been calculated as follows. So that's how you find the memory address of the nth element. Now let's take a look at an example. So it will be much more clear then. Let's say I have this particular array definition. So this is an integer array of size 100. So there are 100 elements in the array, and they ask you this particular question: find the address of the 31st element in the array if the starting address is let's say 6500. So this is the form of question that they might give you. They'll give you an array definition and they'll ask you to find the address of the 31st element in the array if the starting address is 6500. So So we already have the base address, which is 6500. N has a value of 31, which is already given here. The base address is given here. So to find the index, we'll simply do n minus 1, which is 31 minus 1, which is 30. So the index number of the 31st element is 30. We know the size of int is 4. So we do this 30 into 4, which gives us 120. So we multiply the index number with the size of the data type. So the index number multiplied by the size of the data type, which is 30 into 4, which gives us 120. Now we add this value to 6500. So we add them together. So we get 6620, which is our answer. So 6620 is the address of the 31st element in the array. So which is nothing but the address of 31st element. Clear? So if you remember the total process, it is very easy. You must memorize the size of every data type. From the given question, you will get two things. The first thing will be the value of n, which is the number of the element that we are trying to find. The base address you will get from the question also, as well as, so these two things are the only things that are necessary for our calculation. We will know the base address, we will know the number of the element that they are trying to find the address of. You will find the index, multiply the index with the data type size, then add it to the base address and get the address of the concerned element. They might add one more part to this question. Let's say they also ask you, they also ask you to find the total size of the array. Also find the total size of the array. So they might also ask you to find the total size occupied by the array. So it's pretty simple. Remember the first process. You know the size of the data type, which is 4 bytes. You know the size of the array, which is 100. So each element will take 4 bytes and there are a total of 100 elements. So the total size of my array is 400 bytes. So this is the total size of my array. So these two types of questions might be asked: the total size of the array or the address of a particular element in the array. So I hope both of these are clear. So now let's start. Let's get back to our string programs. So the first program for today is pretty simple and easy. So write a program to accept a name containing 3 words. So I'm specifically asking for a name that will have 3 parts: the first name, the middle name and the last name, not more than that. So it will always have a maximum of 3 parts. And display the surname followed by the first name and middle name. So this is a very trivial string program. There's nothing complicated inside this. So if a name consists of 3 words, so it will be the 3 parts will be the first name, the middle name and the last name. So the total name will be of 3 words. So the first word will be the first name, the second word will be the middle name and the last word will be the last name. So in the question, what they have asked you to do is interchange the positions of the last name and the first and middle name. So after interchanging, you will get something like this. The last name will come first, followed by the first name and the middle name. So you're just taking this part out and placing it at the beginning, and the rest of the part is just coming here after the last part. So there are three parts in the name. The last part will come at the beginning, and the first and second parts will just come after that. So it's pretty simple. Let's take a look at the program code. So the logic is pretty simple. Since we have to extract the surname and append it to the beginning of the name, so we will be using two functions. The first function will be the last index of function, which will find out the last space, index of the last space, because just after the last space we will have the surname, and we will use the substring function to extract the surname from the original name. So here is the program code for that. Class, let's call the class name. Inside the class I'll have a string variable, let's call the class name manipulation. Since we are manipulating names, so let's call it name manipulation. So the class is called name manipulation, and I have a variable called string name, and I shall have one more variable which will be called surname to store the surname that I am going to extract from the name. Okay. So I have two variables, string name and string surname. Now I'll directly jump to the functions. As usual, I will not be writing a constructor. I will be using the default constructor. So the first function that I'm going to write is the input function to take input. So I'm separating the input part from the rest of the program. So void input, inside I'll have the scanner object, scanner sc is equal to new scanner system dot in. So I'll have an SOPLN statement, SOPLN enter a name with 3 words. So specifically I mention it to the user to enter 3 words. So name is equal to sc dot next line. Multiple words, so next line function. And that's the end of our void input function. So it's just the normal input function that we usually write. So after we have finished writing the input function, we'll go to write down the function where we are actually manipulating, or rather interchanging, the surname and the first and middle names positions. Let's call that function name change, rather name changer. So it does not take any arguments and does not return any value. So we are calling the function that changes the name changer. Now inside we already have the name that the user has input in the name variable. So we'll just do int L index, which stands for last index, is equal to name dot last index of space. So inside the variable L index, I'll have the last index of space within the name. Next, what I'll do is I have a variable called surname. I'll initialize it to the surname part of the name. So how will I do that? I'll call the substring function. So name dot substring. The starting value will be L index plus 1, and I'll not provide the other arguments. It will just extract it up till the end. So the substring function extracts the surname and stores it in the variable surname. Now I'll just modify the name value of the name variable so that it does not contain the surname part. So I'm just omitting the surname part from the original name. 0, L index. Remember, the last argument is not inclusive, it is exclusive, so it will extract up till just before the last space in the name, which is nothing but the first name and the middle name. Now we'll just display a message modified name, and then we'll display the changes. So we have to first display the surname part. So I'll have surname at the beginning, followed by the concatenation operator and the name part, which has nothing but the first name and the middle name now. And that's the end of our name changer function. Pretty simple. We find the last index of the space. So we find the index number of the last space in the name. So just after the last space we'll have the surname. So I use the substring function to extract the surname, starting from the location of the last index. Next, so starting from the next location of the last index of the last space. Next, I modify the original variable so that it does not have the surname part anymore, because I've already extracted the surname in the variable surname. So I omit the surname part from the original name, and finally I display the surname followed by the name with the first and middle name parts. So that's my void name changer function. Now I'll just write the main function and call these two functions to input and modify the name. So main function will be defined as usual, public static void main string args. Inside I'll create an object. So the class was called name manipulation. Let's call the object obj. I'm calling the constructor, which is the default constructor. So that's our object defined. Now we'll use the object to call the functions. So the first function that we will call is input. Take a name as an input from the user. The second function that we'll call successively is called the name changer function, which will modify our name and display it. And that's the end of our main function, and that's the end of our class. So it's a pretty simple program. There's nothing complicated inside. You just extract the surname, modify the original names so that surname is no longer a part of it, and then finally display the surname followed by the first name and middle name, which is in the original name variable. So we'll take a look at one more program, which will be our last program for today. The next program is write a program to enter a string or sentence preferably, and display the longest word and the length of the longest word, and display the longest word and the length of the longest word. So let's say I have a sentence. So this is my sentence. Tata Football Academy will play against Mohun Bagan. So in this sentence, as per the question, I'll have to find the longest word as well as the number of characters in the longest word, which is the length of the longest word. So if you count the number of characters in each word, you'll see football is the longest word. So you count academy, 1, 2, 3, 4, 5, 6, 7. There are 7 letters, whereas in football there are 8 letters. So football is the longest word, and the length of the longest word is 8. So we'll write the program in such a way such that it displays the longest word as well as the length of the longest word. So in this program, we'll just keep on extracting characters using the charac function, and we'll simultaneously keep on counting the characters being extracted. Once we have encountered a space, we'll already have counted the number of characters in the first word. So we'll have one more variable that stores the length of the longest word, which will be technically initialized to 0. So let's say I have two variables. So one variable will have, rather let's say so let's do it in an easier way. So let's say I extract each and every word. So at first, using the charac function, I extract this word. As soon as I encounter a space, I know that the first word is complete. So I have the first word in, let's say, a variable. Let's have a shorter variable. So let's call the variable in which I'm storing my words as W. And let's say the variable that stores the longest word is LW. So LW stands for longest word and W stands for word, the current word that we have extracted. So from the sentence we'll extract every word and we'll do something like this. So we'll compare the lengths of the current word and the current longest word. So initially longest word will be null. So initially the value of longest word will be null. The value of the word will also be null. So during the first iteration, I'll extract the first word, which is Tata. Now W will be is equal to Tata, and LW is still null because we have not done anything to it yet. Now we'll compare W, the length of W, with the length of LW. How do we do that? We'll use the length function. So W dot length. So we'll compare it like this. If W dot length is greater than the length of the longest word, W dot length. So we are using the length function to on the go calculate the length of each word. So W is the current word, now LW is the longest word, which is initially null at the first iteration. So we'll calculate W length. We'll check if it is greater than the length of the longest word. If it is, we'll just do LW is equal to W, which is now the new longest word, because if the current word is greater than the longest word, then the current word becomes the longest word. That is what we are doing here, and in that way we'll find out the longest word. At the end, when we reach the end of the sentence, we'll have the longest word in LW. We'll just display the longest word, and we'll again call the length function on LW to display the length of the longest word. So let's take a look at the code, and it will be much more clear then. So as usual, we have the import statement. Import java dot util dot scanner. We'll have the class. Let's call the class longest word. Inside the class we'll have a string variable. Let's call it str. Apart from that, we'll not have any more class variables because we don't need them. We directly go to the input function. So void input, no arguments. Inside we'll have the scanner object. as usual, scanner SC is equal to new scanner system dot in. So the void input function is basically the same for every program up until now. So SOPLN, I'll just ask the user to enter a sentence. And str, which is the string variable, is equal to sc dot next line. So take inputs as usual, that's the input function. Now let's move on to the actual function where we'll find the longest word. So let's call the function longest word. Our name is becoming similar to the class name. So let's call it long word. So void long word does not take any arguments inside the function. I already have a sentence, so I'll simply do this. So I'm adding a space, an extra space at the end of the sentence, because I would also have to consider the last word. As you may remember, the number of spaces is one less than the total number of words, which is why I'm adding an extra space at the end of the sentence, so that the number of words equals the number of spaces. Otherwise, we might skip the last word during our iterations. So that's the reason why I'm adding the space at the end of the last word. So the number of words becomes equal to the number of spaces. Therefore, all words will be considered. We'll define two variables here. The word variable, which is the current word initialized to null, and the L word variable, which is the longest word, which is also initialized to null. We'll need these two variables. So one will store the current word extracted, and the next one, L word, will store the longest word amongst all the words that have been processed so far. Both of them are initialized to null. We will also calculate the length of the total string str dot length for our loop. So we'll calculate the length of the string. Now we'll start our loop. So we'll use a for loop. Int I starting from the 0th index. I will run up till less than len length, and I plus plus. Standard for loop syntax. Inside the for loop, we'll extract characters, because there is no function which we can use directly to extract words. So we'll have to extract each and every character until and unless we get a space. So str dot cat I. So we have to extract words in a roundabout way, because there is no direct function already written down to extract words directly from a sentence. So we extract characters and form words. if ch is a space, which means we have already formed a word, right? So inside, we'll simply check if word dot length is greater than L word dot length. Just the checking that I mentioned before starting the program code. If this holds true, I hope you have finished copying up till here. So I'm rubbing off the board. So if this condition holds true, then the new L word will be the current word. That's all we need to do inside the if statement. Also, there's one more thing. So the current L word becomes the L word becomes the current word, and also we need to deinitialize word to null because we have already processed word. So whenever we encounter blank space, we know that we have already formed a word. So we check if the word is greater than the current longest word. So if the current word is greater than the longest word, we just initialize or set the variable longest word to the current word, and we initialize word to again null. So the inner if statement ends here and the outer if statement ends here. Now the else part. If ch is not a space, then we'll just keep on forming the word. So word plus equal to ch. I hope you remember the notation plus equal to. So word plus equal to ch means word is equal to word plus ch. It's just concatenating all the characters to form the word. That's everything inside the else part. So after extracting each character, it will almost always come to the else part. If it is not a space, the extracted character. So inside the else part, the word will be formed. So as soon as you get a space, it goes inside the if statement and checks whether the word thus formed is greater than the current L word. If the current word is greater than L word, then we reinitialize L word to the current word and empty the value inside, stored inside the variable word. Now, after the else part, the for loop ends here. That's the end of the for loop. This is the end of nested if, and this is the end of the outer if. End of outer if. Just putting some comment lines so that you don't get confused. This is the end of the nested if, where we were checking which word is greater. This is the end of the outer if, which was the if checking if the current character is a blank space. And this is the end of the for loop. Now, simply have two things to do. So I'm again rubbing out this whole thing. So we have already found out. So once the for loop ends, we already have the longest word. We'll simply do SOP-ln. The longest word. So there's a space after that. Plus we display the value of L word. Now we also have to display the length of the longest word. We can have a space plus we have the longest word in the variable L word, and we just call the length function here to display it. As simple as that, and that's the end of our function. So that's the end of our long word function. Now we'll have the main method. Public static void main, the usual definition. Inside main, we'll just define an object. The class was called longest word. Obj is the object name. New longest word, which is the constructor, default constructor. Now we'll do obj dot input to call the input function. Now since we have an input, we'll call the obj dot long word function. We simply call the long word function, and that's the end of our main and the end of our class. Okay, so we extract each word, we compare the current word with the previous longest word. If the current word is greater than the previous longest word, we set the current word as the longest word, and we discard the current word. After setting the longest word to current word, we discard the current word value. We repeat the process until the sentence is exhausted. Once the sentence is exhausted, we come out of the for loop and we have the longest word in the L word variable. Now we just display the longest word and call the length function on the longest word to display the length of the word. So that's all for today's class. So we have again done 2 programs today. We'll be looking at a few more programs in the coming classes. So I hope the concept of addresses of arrays and the 2 string programs have been pretty much understood. So thank you for coming to today's class.